Welcome to our third video on systems of equations. So here's an example of a system of equations. In this case, there are two equations. Each one constrains what the possible solutions can be. And we're going to solve this system by substitution. Substitution is such a powerful tool in mathematics. It's possibly the most important thing that we do in mathematics. It's what lets us solve increasingly complex problems. And it's something you've been doing essentially since you were a little kid. If you picked up a stick and made it into an umbrella or a sword or whatever, you pretended. That's what substitution is, essentially. You're pretending that one thing is another. Only in mathematics, sometimes we can go a step further. Besides pretending, we can say this is the other thing. In fact, that's what an equation means, right? This equation, for example, says x equals negative 6y plus 7. Well, that means x is equivalent. That is, it can be given by this alternate expression. These two expressions, x and negative 6y plus 7, are equivalent. That's what the equation tells us. Which means anytime I see an x somewhere, I can replace it with negative 6y plus 7 because they are equal to each other. So we can substitute negative 6y plus 7 wherever we find an x. We're going to do that. In this equation up here, we see x right there. We're going to replace x with what it's equal to, negative 6y plus 7. Let's see what happens when we do that. So this is called substitution. I'll write that. We are substituting this expression for x in the first equation. And it'll look like this. 2 times x, but instead of x, we're writing this, negative 6y plus 7, and then we carry on writing the original equation, minus 9y equals 14. Now, magic occurs here because we have gone from equations with two different variables, x and y, to a new equation with only one variable. There's a y and there's a y. They're the same variable. There's not two different variables, there's only one. And we know how to solve equations where there's only one variable, so we will do that now. And we will find a number that is equal to y. So let's see what happens. We first want to get rid of parentheses. We can't combine our y's until we get this y out of the parentheses somehow, so we can do that by distributing 2 across this addition, and that'll look like this. So 2 times negative 6y is negative 12y. 2 times positive 7 is positive 14. Then we write the rest of it. 9y hasn't changed. Equals 14 hasn't changed. Now that it's in this form, we can combine like terms. So negative 12y minus 9y is negative 21y. And also, we can subtract 14 from both sides of the equation. 14 minus 14 is 0. 14 minus 14 is 0. From this point, we want to get y all by itself. It's being multiplied by negative 21, so we'll have to undo that. Do the opposite operation. That would be multiplication becomes division, so we're dividing by negative 21. And we get y equals, well, 0 divided by anything is 0. And so we have discovered that y, in order to solve this system of equations, y must be 0. There's no other number that will work. Now, look at that. We have a number, y equals 0. Well, if y equals 0, I can replace y in these equations with 0 because they are equivalent to each other. So let's see what happens if we do that with our first equation. We get 2x minus 9 times 0 equals 14. If we do that in the second equation, we get x equals negative 6 times 0 plus 7. Now let's simplify both of them. If we got a true answer for what y is, then both of these equations will give us the same x value. So let's see what happens. Negative 6 times 0 is 0. 0 plus 7 is 7. So this equation becomes x equals 7. The top equation, 2x minus 9 times 0. 9 times 0 is 0. So 2x equals 14. And if we divide by 2, we get x equals 7. And you'll notice that these are both the same equation. So we now know that y has to be 0 and x has to be 7. Okay, so the solution to this set of equations right here, the solution is the point 7, comma 0. X is 7, y is 0, satisfies both of the constraints or equations in our system. And we're done.